So we've already been talking for about 45 minutes, a bunch of us, getting together again. It's been fun. I wish we could do it in person. I want to welcome everybody to tonight's first ever Maimonides Society Zoom meeting. And I wish to thank Becca Allen, who's, you may have seen, those of you who were on earlier. She is the Communication and Events Coordinator for the Jewish Federation of Raleigh-Cary, and she's been working behind the scenes to make tonight's program possible. So it's no secret that these are very tough times for nonprofits. They are scrambling to provide for the increasing demands for services while facing monumental funding challenges. And before talking about that, I'm going to bring up one bright spot. We started talking about it earlier. The Federation called upon us, the Maimonides Society, to form a medical task force on which I was privileged to serve with Doctors Jeff Engel, Hope Seidel, Suzanne Zorn, who's here tonight, Joanna Kipnis, as well as Elaine Hubble. Largely through the dedication and hard work of Beth Richmond and Barry Schwartz, and guided by the expertise of the task force, the JCC was able to provide a much needed and fun-filled summer camp experience for countless children, as well as relief for their very stretched moms and dads. As you know, the JFS, Jewish Family Services, has continued to serve the growing needs of our community through its counseling services and food provisions during this trying time. And the JCRC has been reconstituted and has been holding an election series of Zoom events. Unfortunately, you've missed most of them, including David Price, who's talking right now. But Jonah Kaplan of ABC 11 will be having one final interview on Monday, October 26th at 7 p.m. with Roy Cooper. Previously, he interviewed the challenger, current Lieutenant Governor Dan Forrest. So now I'm going to make the pitch. Through a generous initiative from the Jewish Federation of North America, new donations and renewed gifts are now eligible for a 50% match for our local Jewish Federation of Raleigh-Cary. I hope you will consider helping the Federation continue to serve the community by giving generously to our annual campaign. Please join now and help us reach our goal to receive these matching funds. On today's program, David is going to speak for, I think, about 20 to 30 minutes, and you will all be muted during that time. Then he will take questions, and if you'd like to ask a question, please just type something into the chat link below, and we will call on you and unmute your microphone. But please remember to be brief. Now, for my introduction. Dr. David Fajgenbaum is a groundbreaking physician scientist and writer of an acclaimed memoir, Chasing My Cure, a doctor's race to turn hope into action. In it, he recounts facing death while in medical school and nearly dying 4 more times battling Castleman disease, a rare, deadly cytokine storm disorder. To try to save his own life, he spearheaded an innovative approach to research through the Castleman Disease Collaborative Network and discovered a treatment that has put him into his longest remission ever. Now he is applying this approach to battling COVID-19, which, like Castleman disease, involves a cytokine storm mechanism. He is one of the youngest individuals ever appointed to the faculty of University of Pennsylvania Medical School. He has published many scientific papers, including one that was recently selected by Stat News as one of the best innovations in science and medicine this year. David has been profiled by the New York Times, as well as by Good Morning America, CNN, and the Today Show, among others. He earned a Bachelor of Sciences from Georgetown University, a Master's in Science from the University of Oxford, his MD from the University of Pennsylvania, and an MBA from the Wharton School. As you all know, he is from Raleigh and went to Ravenscroft School with my own kids, Matthew and Emily. It is now my great pleasure to welcome David to tonight's program. Thank you, David.
Oh, thank you so much for that introduction, Michael. It's really an honor to be with all of you tonight. And it's extra special that you guys are obviously all in the Triangle area, and just really happy to spend some time with you guys tonight. So Michael had asked me to put together a presentation, and so I've done that. It'll be about 20, maybe 30 minutes long. Feel free to put messages into the chat if there's questions that come to mind, so that way or you don't forget to ask them, or I don't forget to answer them until we get to the end of the talk. So I'm going to start out by sharing my screen, and you should see everything sharing okay, Mike?
Yep.
Excellent. So I titled my talk "Chasing My Cure" because I've been in a race against time and a chase after a cure for my own condition for the last 10 years. This picture on the left of the screen is from me when I was a healthy third-year medical student at the University of Pennsylvania, where I had hoped to one day become an oncologist and treat cancer patients in memory of my mom, who some of you all actually may have known. When out of nowhere, I went from being this healthy medical student to becoming deathly ill. I experienced liver, kidney, bone marrow failure. I gained 70 pounds of fluid. I drifted in and out of consciousness and required blood transfusions daily. I was on dialysis, getting dialysis 3 times a week, and really just teetering with death. In fact, I was so sick that my doctors encouraged my family to come in and say their goodbyes to me in November of 2010. And I've really considered that moment to be the start of my overtime. And of course, I like to think about the sports analogy of overtime. You all will understand it. In overtime, it's extra time you didn't think you'd have, but it's time where you really have to make the most of every moment. And so I've tried really, really hard since that day to make the most of my overtime. As I think about overtime, I like to think about, well, if my overtime started in November of 2010, then what was the first half of my life? What was the second half of my life? And for me, the first half of my life was growing up in Raleigh. This is a picture of my mom and I on the day that I graduated from Ravenscroft for high school. And I was getting ready to head off to college. And my life just completely was shattered about 2 weeks later when my mom was diagnosed with glioblastoma brain tumor, a terminal form of brain cancer. And I was incredibly close with my mom. She was a really special person. I hope some of you all maybe knew her. She was a very special person, and finding out about her diagnosis really just crushed me, that someone, so special and so kind could have such an awful diagnosis. So I rushed down back to North Carolina, and she went to the Duke Brain Tumor Center. And I remember passing a sign, this particular sign on the wall. It said, "At Duke, there is hope." I remember feeling comfortable and feeling good knowing that she was at Duke, the world's best brain tumor center, and that there really could be hope because we were at the right place. We didn't need to do anything other than just get to Duke, and Duke would be able to take care of us. Over the next 15 months, my mom battled cancer bravely. This is shortly before she passed away. And I have some amazing memories from the time while she was battling cancer, because she just was so brave and was such a strong person. Shortly before she passed away, I had my final conversation with her, and that's where I told her I was going to create something in her memory for college students who were dealing with the illness or death of a loved one. Her and I had spoken a lot about the challenges of being a college student and what it was like being away from home all alone while my mom was sick. So I told her I would start something in her memory. I would call it AMF. I didn't know what AMF would stand for, but it went on to, my mom's initials were AMF, Anne Marie Fajgenbaum. So I knew it should stand for AMF, but I didn't know what it actually would mean beyond that. So we then went on to call it Ailing Mothers and Fathers. And then more recently, I guess recently, everything's relative. About 10 years ago, we switched it to Actively Moving Forward. So AMF is still around, supporting students around the country, coping with illness and death, and actively moving forward after their loss. We raised a lot of awareness over the years. I was actually on the back of 40 million bags of Doritos back in 2008, which really raised a lot of awareness. It's amazing how many college students eat Doritos, but it really did get the word out in a really important way. So fast forward to how I started my talk, and here I am in 2010, really on my deathbed with this mysterious illness, not knowing what it was. In fact, I was so sick at one point, just a couple days before my family came in to say their goodbyes. I was suffering so much. I was in so much pain that I really hit my rock bottom. And I think that oftentimes when I give this talk, I share about all the highlights, and it sounds like, oh, it was just a bunch of like successes. And of course, that's not the case. There were a lot of valleys for every peak. And I think that probably one of my lowest valleys was just before my family said their goodbyes to me. And it was when I was in just so much pain, my whole body, because of the fluid accumulation around my vital organs. It's hard to describe the pain and the suffering that my family and I were going through. And I remember seeing a telephone, my hospital telephone right next to my bed, and looking at that cord. And for just a split second, it wasn't probably longer than a quarter of a second, but for a split second, I thought about, I'm suffering so much. My family is suffering so much. I'm going to die in the next couple of days anyway. Maybe I should just give up right now. Maybe that telephone cord will be my way out of this thing. And thinking about that now is devastating, because of course I would have had no idea what I was giving up on. My sweet 2-year-old daughter is downstairs eating dinner right now. And I'm thankfully doing well right now. But at the time I thought my horizon was about 1 or 2 days. And I thought, maybe this will alleviate the suffering. And thankfully I snapped out of it. And thankfully, I didn't reach towards that telephone cord. But I think it's important to share that as really a low point for me. But I think many of us go through low points. So I want to talk about, and throughout my talk, I have a few passages. This is really about overtime. So the experience of being in overtime is surprisingly one of intense awareness and scrutiny and clarity. There's a reason for that. When there are only a few seconds left on the board, all distractions disappear and the purpose, victory, becomes clear. The present is only the things around you, and overtime is all present. Nothing but present purpose. And so for me, that low point was followed by me realizing that I wasn't going to give up, and I was going to keep fighting back. And not only was I going to fight for survival, but I was really going to fight to make the most of every second. I was going to live like I'm in overtime. And thankfully, I finally received my diagnosis within about 48 hours of that low point. And with the diagnosis came treatment. I was given a combination of 7 different chemotherapies. Those drugs thankfully saved my life. The diagnosis was idiopathic multicentric Castleman disease, which is a rare immune system disorder where your immune system attacks your vital organs. And the only way to stop it is by just wiping out your immune system with chemotherapy. So this combination of 7 chemotherapy agents saved my life. And you can see my dad and I'm sitting up and just so thankful to be alive. This is another picture from a couple of days later when I'm finally standing up. This is about 5 months into my medical journey. And I'm just so thankful to be alive. So my dad and I decided to take a walk around the hematology oncology floor. And it actually happens to be New Year's Eve 2010. I mentioned I got sick in August 2010. Now here we are, December 31st, 2010. And I want to share an anecdote from that night. There was a gentleman who was in the family waiting area who was kind of like swaying in his chair. He'd clearly been drinking on New Year's Eve. He was definitely drunk on New Year's Eve. And in our next lap, we saw that he had fallen onto the ground. And so my dad ran over to him and helped him back into his chair. And he looked at my dad and I, and he said, "Thanks so much. Good luck to you and your wife." We're like, "Wife? What is he talking about?" And then I looked at my belly and I realized that he thought that I was my dad's pregnant wife and that we were walking laps to deliver our child, which was a low point emotionally for both of us. But I turned to my dad, I said, "Man, Dad, you've got an ugly wife." And we really laughed so hard. And maybe you can see how someone might have confused me as my dad's pregnant wife. You can see I had a big belly from the liver and kidney failure and just tremendous fluid accumulation. This is about 7 weeks later. So I actually was looking a lot better at this stage than I was previously, if you can imagine that. And then this picture is from a few years before. I played college football at Georgetown. I was a quarterback there. And I always say this is like the worst before and after picture of all time. But if we could flip the order, it would be this amazing advertisement for Muscle Milk or Peloton. But unfortunately, it's in the wrong order. So I got out of the hospital and I took a picture every week for the next 8 weeks. And you can see by the end of the 8 weeks, I look less like my dad's pregnant wife. When I got out of the hospital, one thing that I'd spent a lot of time thinking about while I was in the hospital was the girl I had dated just before I got sick. I dated Caitlin Fajgenbaum now, but Caitlin Presenica. She's lived in Raleigh, and you guys may have known her family. But we dated for a few years before I got sick, and we broke up just a couple months before I became ill. And when we broke up, it was kind of the idea that we're young, 25 years old, we got all the time in the world. If it's meant to be, it's meant to be. And there I was in the ICU just a couple months later without all the time in the world, literally on my deathbed. And so when I got out of the hospital, I committed that I would never live this life thinking that, like, we've got all the time in the world. And so I turned to and reached out to Caitlin, and thankfully she felt the same way as me. And we started dating again. This is the first Halloween after we started dating again. And I hope you guys recognize that I'm dressed as Borat. You may not remember Borat, Sacha Baron Cohen, but he is my hero. And he's actually got Borat 2 is coming out on October 23rd. So I hope everyone tunes in for it. But so this is me dressed as Borat on Halloween and celebrating that Halloween with Caitlin. This is a really important picture to me because it's of me. It's a few months later, and I'm getting an infusion of an experimental drug called siltuximab. I was getting the drug every 3 weeks. And this particular infusion, they let me leave the infusion suite. So I have a pump on my shoulder, and I'm getting my experimental infusion through the pump. And I think it's really an important picture to me because I think it's so symbolic. On one shoulder, I'm getting this experimental drug that is helping me, maybe saving my life. And on the other shoulder, I've got Caitlin, who I'm leaning on. And I think this is really symbolic of just my life over the last 10 years, medication treating me, and Caitlin, my family, my loved ones supporting me during really tough times. So I returned to Penn for medical school, or I was a third-year student to finish my third year, and then I relapsed on the only drug in development. So that experimental drug I was on, only drug to ever undergo a randomized controlled trial for my disease, it now wasn't working for me. And so all of a sudden, I learned that not only was this drug not working for me, but there actually were no more drugs in development. And so I turned to my dad, my sisters, and Caitlin, and I said, I'm going to dedicate the rest of my life to trying to find something that could save my life. And so the first thing I did was begin conducting laboratory research at Penn. There was no one studying Castleman's at Penn, but a researcher there generously gave me some space in her lab. And I started performing studies on the only samples I could get my hands on, which were my own. But I knew that I was unlikely to make progress in time to save my own life. And so I started a foundation called the Castleman Disease Collaborative Network with the goal of bringing together physicians, researchers, and patients worldwide to really advance research on a global scale. And I think this is a really important moment for me. And that was when I went from being a very hopeful, optimistic person that I could kind of hope that someone somewhere would figure out my disease, to realizing that hope cannot be a passive concept. It's a choice and a force. Hoping for something takes more than casting out a wish to the universe and waiting for it to occur. Hope should inspire action. And when it does inspire action in medicine and science, that hope can become a reality beyond your wildest dreams. And so for me, I was committed to turning hope into action. So I wanted to just share kind of where we were back in 2012, and I'll go through this quickly, but basically there's about $10,000 a year going towards studying idiopathic multicentric Castleman disease, which is basically no money, and you're not going to get anywhere with that amount. There was no federal funding going towards IMCD, no registry. There were 2 organizations that existed, but there was no research plan. There were no cell lines or animal models. The disease was poorly understood. There was no diagnostic criteria, no treatment guidelines, no blood tests you could run to predict whether you get better on one drug or another, no FDA-approved therapies, and only one drug in development. And that one drug in development didn't work for me. So here I was really feeling like I was all alone on an island, but realizing that I guess if I'm going to use the analogy of I was all alone on an island, I maybe had a couple coconut trees and maybe an axe, and I said, okay, well maybe I can make a raft out of this. But I certainly felt alone on this island. A little bit about Castleman disease. I know that most or all of you all are physicians. Castleman disease is a rare immune system disorder that we actually have not been able to classify as to whether we should consider it a lymphoma or an autoimmune condition. There are actually features of both. There are features of autoimmunity, and there's also lymphoproliferation that we typically see with lymphoma. But at the end of the day, there's a cytokine storm. The immune system just gets out of control. And back in the 90s, a researcher in Japan discovered that a particular cytokine called interleukin-6 was really the problem cytokine, that maybe if you could block IL-6, patients would get better. But even still, we never knew why the interleukin-6 was elevated. What signaling pathways, cell types, what was the etiology underlying the cytokine storm. But importantly, regardless of why IL-6 was elevated, we knew that interleukin-6 blockers like cetuximab were actually quite effective. So in a third of patients, the drug that I was on actually eliminates and stops the disease if you block this one cytokine with a drug called cetuximab. Unfortunately, I fall into the 2/3 of patients where we don't benefit from IL-6 blockade. And for patients like us, where we don't know what to block, we just use cytotoxic chemotherapy, just obliterate the entire immune system. It was Kazuo Yoshizaki, photographed here, who was the person who discovered interleukin-6 to be important in Castleman's. He made the discovery it was important. He developed a drug called Actemra, or tocilizumab, which many of you all will be familiar with, to treat patients with Castleman disease. And amazingly, I heard a rumor that he tested tocilizumab on himself. He gave it to himself to prove that it was safe before he gave it to other patients or to other humans. And when I asked Kazu, because Kazu's a very good friend of mine, I asked Kazu, I said, Kazu Makoto just told me that you gave yourself tocilizumab to prove that it was safe. And he said, no, I didn't give it to myself. The nurse, she gave it to me. So Kazu Yoshizaki discovered interleukin-6 as the target. He developed tocilizumab, Actemra, which many of you all are familiar with, to block interleukin-6 signaling. And then he gave it to himself. He didn't die, so he went on to give it to other people. It got approval in Japan for Castleman disease, and then it came to the United States about 20 years ago, and it was tried for rheumatoid arthritis, and more recently for CART therapy, the cytokine storm that occurs after patients get immunotherapy. It's just amazing. And you may have followed the CART therapy story here at Penn, where we engineer T cells to kill cancer. And the first patient who got CART therapy at Penn is a young girl named Emily Whitehead, photographed here. Emily was dying in the intensive care unit with a syndrome that looked almost identical to Castleman disease. It looked just like me when I was in the ICU. And the doctors decided to treat her with tocilizumab, this drug that blocks interleukin-6 receptor, this drug that Kazu developed 30 years before for Castleman's, and it saved Emily's life. And in saving her life, obviously, it's so important in its own right, but also importantly, it saved the entire CART therapy program, because if the very first patient who got chimeric antigen receptor T cells died, I can promise you the entire program would have been shut down for 5 or maybe 10 years. Thankfully, it wasn't shut down, and it's actually one of the most promising areas in all of cancer research and all of cancer therapies. You probably saw and maybe heard that when COVID struck, a lot of people started trying tocilizumab because, again, the similarities between idiopathic multicentric Castleman disease and the cytokine storm we see in COVID. And there were a lot of anecdotal reports that it seemed to be effective. Unfortunately, the clinical trials have been a bit contradictory. So there were initial ones that suggested it was effective, and then a follow-on phase 3 study that suggested it wasn't effective, and then more recently, another phase 3 study that suggests maybe it is helpful. I think like everything in COVID, it's very complicated, and it's probably really dependent on the kind of patient you select and you give the drug to. So kind of jumping back to my journey with Castleman's, I knew that I couldn't do this alone. And so I began to assemble a team, first of medical student classmates of mine, and then business school classmates, because when I finished medical school, I went to business school, and I assembled a team of these amazing medical school and business school students who joined in as part of this fight. We were doing what we call the Castleman Flex. Benjamin Castleman was a doctor from Boston who was a Jewish man who discovered and described Castleman disease for the first time, named it after himself. But we've kind of repurposed the idea of the name Castleman to be like a man in a castle. So we do like a Castleman Flex, which if we were all together, I would ask all of you to do this Castleman Flex. But maybe you guys will do it separately and send in some pictures. So in addition to building this team, we also began to enlist physicians and researchers from around the world to be part of our network. We knew that if we really wanted to make progress, we would need physicians, researchers, and patients all contributing ideas towards research and crowdsourcing from those ideas. And so these are just a few of the many that are part of our community. I'm not going to go through all the studies, but you can go to cdcn.org/research to see what research we have going on right now. When I started out, there was one study underway. Now there are well over 30 that we've been able to fund, some of which are completed, some of which we're still raising funds for. But it's just really exciting to see the progress we've made. So in the midst of this progress, I mentioned I graduated from medical school, got engaged to Caitlin, and we had a wedding date in our mind, May 24th, 2014, when unfortunately I relapsed again, this time while I was on chemotherapy. And so now I was out of options, and what do you do when there are no more options? And so for us, we decided we wanted to come up with a new approach. And I'll go through this quickly, but basically we ran cytokine panels on my blood every month leading up to my relapse. We didn't know I was going to relapse, but we suspected I probably would. And those cytokine panels led us to identify a particular cytokine called VEGF, or vascular endothelial growth factor, which many of you all will be familiar with, which is really important for blood vessel growth, and also another cytokine, or a cytokine receptor, called the interleukin-2 receptor, soluble IL-2 receptor, which is expressed by activated T cells, or it's shed by activated T cells. So this proteomic data suggested to us that maybe VEGF and T cell activation were involved in my disease, because everything goes haywire when I'm in the ICU. But what were the things that changed in the time leading up to my ICU stay? I was able to confirm that there was T cell activation, increased VEGF from the samples I had stored. And then we were able to look at my clinical picture and see some nice correlates. So VEGF, I mentioned, is involved in blood vessel growth, while my lymph node was riddled with blood vessels in kind of every direction. I had these cherry hemangiomas appearing on my skin that, again, could be consistent with the role of VEGF. And then the really tremendous fluid accumulation can also be caused when you have very high VEGF levels. So the question became, what could potentially be involved in the cytokine production, T cell activation, and VEGF that we were finding? And we ran my data through what we call this pathway analyses, or multiple pathway analyses tools, to ask the question, are there any particular cellular communication lines or pathways that may be involved in all three of these things: cytokine production, T cell activation, and VEGF? And the bioinformatic analyses predicted that the mTOR pathway may in fact be a central driver that's involved in all of these. And so we decided to do a final and key experiment to say mTOR is important for cellular proliferation. It's important for the immune system to communicate with other immune cells. But we wanted to see, is the mTOR pathway really activated in my samples? And there's a really simple experiment that we did. And we looked at normal lymph node tissue, and we stained it for a marker of mTOR activation called phospho-S6. And you can see in this normal lymph node that there's some cells that stain positive. There's some mTOR activation in a normal lymph node. And we did this in a number of normal lymph nodes. And then this is my lymph node, and you can see that there's just a tremendous amount of mTOR activation, way more brown than there is blue in my lymph node, which really confirmed what our hunch was, and that's that the mTOR pathway was active. And so then the question became, well, should we try an mTOR inhibitor like sirolimus that's really good at blocking mTOR activation? And we did. And today marks 81.29 months since my last relapse. And I say the 0.29 months because I know that I can't round up. I don't know if I'm going to be in remission until 82 months, but I also refuse to round down because we've worked really hard for that 0.29 months, and we'll take every fraction of a remission that we can. The New York Times called this "Doctor Cure Thyself," which I think is a bit of an overstatement. I think it should probably be doctor helping himself a little bit right now and hopefully for a lot longer, but I don't think that would have fit as a headline. Importantly, it gave us time to make it to Caitlin and I's wedding date, May 24th, 2014. And actually in this picture, that's never before been cut hair that you're seeing in the photo. It grew back just in time so that I would have hair on my wedding day, which is actually pretty important to me. And then a couple years ago, Caitlin and I had our daughter Amelia. This is her right around her first birthday. And then this is Amelia just a few weeks ago around her second birthday, or on her second birthday. So I know as physicians, you guys are probably all wondering, well, what else have you done with mTOR activation and this work? And so we've done further research. We published last year on this discovery and the use of mTOR inhibitors in 3 patients. And then we went on to discover and describe mTOR activation across 26 Castleman's patients, and more recently discover a potential candidate driver. So we think type 1 interferon signaling could explain why there's increased mTOR activation. So from the research that we do in my lab, I run a Center for Cytokine Storm Treatment Laboratory. So from the research we've done in my lab, we've then decided to try this drug in other patients, not just me, but this is a patient, Joey, who benefited tremendously from sirolimus. But unfortunately, it hasn't helped everyone. This is Lisa and Sergio, who both received sirolimus as third-line therapies. And unfortunately, sirolimus was not able to help them, and they unfortunately passed away shortly after their administration. And so patients like them really drive us to keep fighting for more and more answers. I'm right towards the end of my talk, but I do want to share kind of where we are today, so you can see where we were back in 2012 in white, and I'm going to superimpose where we are today. So we raised about $1.4 million for research. We've spent the $1.4 million on research, and then external organizations, the federal government, nonprofit organizations have then invested an additional $10.1 million into Castleman's research. So though we never could have raised $11 million, I mean, I literally worked as hard as I possibly could to get the 1.4. By raising 1.4 million and putting it into the right studies by the right researchers that have big impact for patients, that has led other people to then throw in $10 million on top of it, which has really enabled the work that we've been able to do. So then NIH funded my lab for the first Castleman's grant ever a couple years ago. We've got a registry with over 1,000 patients. We now have one unified collaborative network. We've got a biobank. We're answering a lot of questions. We published the first ever diagnostic criteria for my form of Castleman disease. We just recently got acceptance to publish diagnostic criteria for another form of Castleman disease. For the first time ever, there are actually diagnostic criteria, and same thing with treatment guidelines. We published the first ever predictive biomarkers for whether you will get better or not with therapy. That drug, siltuximab, went on to get FDA approval, and then now there are two drugs in development based research done in my lab. One drug is a drug I'm on, sirolimus. Another drug is a drug that blocks a signaling pathway called JAK. It blocks the JAK1/2 signaling pathway called ruxolitinib. So Mike actually had asked if I talk a little bit about our corona work, and so I will take a couple minutes now to highlight it. So back in March, I was actually driving down to Raleigh to see my sister and brother-in-law. My brother-in-law tragically was ill with ALS for the last 4 years, and actually just passed away last month from his ALS. And I was driving down when COVID hit on March. Well, COVID, of course, started hitting the States back in January or February, but when things really got bad on March 13th, and I knew that we were going into quarantine, Caitlin, me, and Amelia loaded into my car, and we started driving down to Raleigh because we didn't know how long this quarantine would be, and we really wanted to see Chris because we knew how sick he was. So we were driving down to North Carolina on that to be a Friday the 13th of March, and late that night, I was listening to the news about this coronavirus and what it was doing, and I found myself hoping that someone somewhere would read the research we've been doing for the last 8 years on cytokine storm, would look at the data we've generated around how do you stop them, would follow our approach for repurposing drugs. And about 30 seconds later, I was like, wait a minute, why should I just hope that someone somewhere will follow our work? Maybe we should do it. And so I called my team the first thing that Monday morning, and we decided to throw our hats in the ring. And so we started something called the Corona Project, which is the COVID-19 registry of off-label and new agents, with the goal of collecting data on all treatments given to any patient with COVID-19 worldwide. And so these are the drugs that have been given to humans with COVID-19 and really have been blown away. Anyone can access the data. If you go to cdc.org/corona, you can access the data totally free. We have a team of over 80 volunteers, mostly medical students, who've gone through over 20,000 papers and pulled out data on over 100,000 patients. Amazingly, over 300 drugs have already been given to COVID-19 patients. So we hear about the same 5 drugs in the news every day, but actually over 300 drugs, so more than 1 in 10 drugs approved by the FDA for anything have been tried on COVID. Doctors and researchers have thrown so many things at COVID patients. One of the problems is that many of these studies have been underpowered. So rather than focusing on, let's say, 100 drugs and having large studies, we've thrown 300 drugs or more than 300 drugs at patients. But regardless, we're collecting this data in an open source database. We share the data directly with the FDA. And we published our first paper on this back in May. We've got another paper that's under review describing this work. And really, the bottom line is that for COVID, you can target one of 3 things. You can target the virus directly. You can target the immune system by boosting it, or you can target the immune system by suppressing it. So it's one of those three things. That's how we treat COVID. Technically, a fourth thing might be to address the symptoms that are secondary to the virus. So maybe you can hit four things, but we've really focused on the latter two, so the immune response, and the question of if you have too weak of an immune response versus if you have too strong. So some patients have too weak of an immune response against COVID. Oftentimes, the early response to COVID is just too weak. And then some people have too strong of an immune response. That typically happens late in the course of disease. And so the work that we've done has really been focusing on what aspects of the immune system could we target. And of course, dexamethasone is not very targeted, it's very general. But in patients who are having too strong of an immune response to COVID, their immune system's too active, which often is late stage, if you give dexamethasone, you can move that immune response more to where it needs to be, which is a balanced, modulated immune response. But if you give dex to someone who's got a modulated immune response, you actually make it worse because now you've weakened what was an appropriate response. And of course, if you have too weak of a response, you're going to be much worse off. The flip side of that is a drug like interferon beta or interferon alpha, which is actually a cytokine that stimulates the immune response. So if you got someone who's got too weak of an immune response, it's very early stage, you give them interferon beta, that'll actually stimulate the immune response and get it closer to where you want it, which is right down the middle, a nice modulated immune response. But if you give interferon beta to someone who's got a good immune response, you're going to create a hyper response. So it's really about threading the needle of making sure that you are getting the right patient, the right drug at the right time. Because like I said, dexamethasone to the exact same patient, if given early, will be detrimental, but if given late could actually be useful, which seems a little counterintuitive. So the bottom line is it's complicated, it's heterogeneous, and we need randomized controlled trials to really be able to say if drugs work or they don't work. I'm going to skip this slide, but it's basically to say that we've been using our COVID work really as a model for thinking about drug repurposing more generally. And this is second to last slide, I believe. We've got on this slide about 10,000 icons, and they represent the about 10,000 known human diseases. Amazingly, out of the 10,000 known human diseases, there are FDA-approved compounds for about 1/4 of them. So, we like to think we've made a lot of progress in medicine and science, and we have, but 3/4 of human diseases don't have an approved compound or approved drug. I mean, thankfully, most of the ones that don't have drugs are rare conditions. So we're talking about the long tail of medicine. The more common conditions have approved drugs, some of them many, but there's about 7,000 diseases that don't have any approved treatments. And so I like to think about this in terms of repurposing. So this is a cartoon of an old dog reading a book about new tricks. And I like to think about old drugs that can be used in new ways. So drugs like sirolimus that were developed 30 years ago for kidney transplantation, we've repurposed them to save my life. How many other drugs are already out there that are approved for one thing that if we could teach them a new trick to be used in another way? So this is my last slide, and I've just got some lessons that I want to close with. The first is the incredible power that comes when patients are part of the research process. Also that hope can have many different forms. I talked at the beginning about how at Duke there is hope, and the hope that came from just being there, that was enough. To then as I progressed in my own disease, I realized that I couldn't just be there. I needed to turn my hope into action. I needed to actually take action based on that which I was hoping for. Another is how therapeutic supporting other people can be. I learned that from my mom. I learned that from AMF. The power that comes from laughter. I hope none of you are ever confused as your father's pregnant wife. But if you are, I hope you can laugh about that and the other challenges in life. I think that it's important to laugh with the people you love, even in the midst of some really tough times. Another is that solutions can be hiding in plain sight. The drug that I'm on that's saving my life was at my neighborhood CVS for years while I was in and out of the ICU. How many other drugs are just sitting there on the shelf? Another is that you can't give up. We have to pivot and adapt. COVID has taught us that our worlds can change in an instant, and we really can't be stuck in our old ways. For physicians, I think it's important to remember that we have to communicate our limits. If my doctor hadn't expressed to me just how much work was needed for Castleman disease, I wouldn't have gotten involved in the fight against Castleman's, and I would have just kind of sat back and waited and hoped. But because he was clear with me about the limits of science, that helped me to want to get involved. I think it's important to systematically capture and integrate data. I'm alive today because of the drug that we discovered based on the scientific data that we generated. In fact, a lot of that data, so a lot of that data we generated in my lab, a lot of that data was just in my medical records that just needed to be harnessed. So we need to do this on a really systematic basis. Another is that you really need a quarterback to facilitate the connections within the system. We like to think that that the whole system works together well. I think you all know better than that, that it does work well a lot of the time. But when it comes to research, it's not going to happen unless there's someone quarterbacking it and championing things through. And really the last one is that it really takes an army. My book is called Chasing My Cure, but I think it should have been called Chasing Our Cures, because it really has been a team effort. You guys have seen a lot of people photographed in the slides. There are a lot more people that weren't photographed that have been a part of this. So I hope you all will be a part of this army. I hope, if you haven't read Chasing My Cure yet, I hope you'll check it out. We talk about Rex Hospital in there, talk about NC State and what it was like growing up in Raleigh, and really the impact that my family had on me. So thank you guys so much. I hope this was Mike, in the realm of what you were looking for, and I'm just really delighted to answer any and all questions you guys may have. So thank you guys.
Wow.
Oh, thank you.
I did.
Thank
That
you.
was compelling, inspiring, so well done. You are a natural teacher among many of your highest qualities. Thank you. I forgot to mention before you came on, many of us were reminiscing about your father and your uncle, and Emily a little bit about you as well. But let me see whether I have any questions. Is there a question?
There's a handful of questions in the chat.
Yeah, I was gonna say we have a couple in there. So
Okay.
I don't know if some of them have been answered or not, but
Let me start with my own question. Have any of the medications that were tried on Castleman disease, have they been tried on COVID yet?
Yeah, so the first that was notably is that drug tocilizumab, the drug that Kazu developed for Castleman's and is approved in Japan for Castleman's. That's been used extensively for COVID. A lot of doctors are swearing by it and saying that it's really saved their patients' lives. The randomized controlled trials have had some positive, some negative results. Another drug, dexamethasone, I mentioned as well, non-specific corticosteroid is used like candy in Castleman disease as an immunosuppressant. It's typically not very effective in Castleman's, but it looks effective in COVID. And then sirolimus, the drug I'm on, actually is undergoing randomized controlled trials right now for COVID, in part because of the immunosuppressive, immunomodulatory effects of mTOR inhibition. So yeah, I mean, it's actually pretty incredible as we look at, those are just three of many, as we look through the list of drugs that are used for COVID, many of them, at least the ones not targeting the virus, anything targeting the immune system, they've probably all either been tried or at least considered in Castleman disease, because the syndrome, the clinical picture is almost indistinguishable. And if you look in the blood of a Castleman's patient and the blood of a COVID-19 patient who's in the ICU, it's very difficult to distinguish the cytokine profile, what's happening in these immune cells. There's this just tremendous immune activation. Of course, in COVID, we know it's because of the SARS-CoV-2 virus. In idiopathic multicentric Castleman disease, we don't know why the immune system's out of control.
Becca, are you controlling the who can talk? I think Alan.
I can't. Let me know who you want me to unmute.
Alan Kritz had a question.
All right.
I think. And then Emily had a question.
Okay. I think I got it.
No.
Okay, I didn't. Maybe we might be doing it at the same time.
Yeah, I think we're good now.
Sorry
hey,
about
David,
that.
Al, Chris, great talk. Is there any evidence that the disease is clonal?
So there is, but interestingly, we haven't found clonality in either B cells or T cells, which are the typical cells that are clonal in lymphomas. We found, and we're still hot on the case, we found clonality from some really kind of old school methods in lymph node tissue, and they're not B cells or T cells. So we actually are thinking that it might be clonality of stromal cells. Stromal cells are basically kind of like the architecture of the lymph node. And so we're chasing after it, and it could just be kind of bystander, true, unrelated. But surprisingly, the B cells and the T cells are not clonal, but we do find clonality in the lymph nodes. So we're hot on the case. But and the reason Alan's asking this is because this sounds like a lymphoma in many ways, and actually it's often misdiagnosed. Either we think someone has lymphoma, they have Castleman's, or we think they have Castleman's, they have lymphoma. But the hallmarks of lymphoma would be that you'd either have clonal B cells or T cells, and we don't see those in Castleman's.
How do you look for clonality in stromal cells?
So you do something called a Humira assay. It's spelled just like the drug Humira. And actually it's where you look in females only, and because of female X-linked inactivation, there should be a random, every cell randomly will turn off either one X chromosome or the other X chromosome, because every cell only needs one X. And so if you look in women's lymph node tissue and you ask about which chromosome is represented, it should be about 50% because it should be random. This gets turned off or that gets turned off. If there's clonality within a tissue sample, that means that one cell is proliferated. You can detect it because there's actually a non-random distribution towards that X chromosome that clonal cell actually has, or that has not inactivated, which is a very old technique. It's actually how back in the 80s and 90s, people would determine that there was lymphoma because you could pick up B and T cell clonality before. Now all the new ways of using PCR and B cell and T cell repertoire profiling. So it's an old technique that we're using.
Interesting. Okay.
Yeah.
Thank you.
Yeah, absolutely. And so we're hot on the case. I guess my answer is that yes, there's some clonality. We don't know what it means, but hopefully in the next year or two, we'll be able to say with definitive.
Have you found clonality in like multiple lymph nodes in different areas in the same person? So in other words, lymph node in the mediastinum versus lymph node in the inguinal area. Great
question. So, and when I said we found clonality, we've actually been trying to validate what another group showed. So it was another group, it was actually a group in Taiwan that showed it initially. And so we're setting up the assays to try to validate it. And so it's actually in our hands. We haven't been able to look yet in multiple lymph nodes. So that's why I feel a little shaky about the result, because we haven't validated it yet. But that's a great idea.
I'm an oncologist, by the way. So
nice. I figured so. I figured about the questions. Okay. Do you do heme or do you do mostly solid work?
I do both.
Oh, cool.
Oncologist. Yeah.
Nice. Treat any Castleman's patients ever?
I've never had a multicentric Castleman's. We've had some unicentric, who they've been not ill.
Yep.
But looking for the disease for 30 years, haven't had any. So now I'm ready for it.
Now you're ready. Yes, I'm happy to hear that.
So I have a question that I'm going to go on, and then I'd like to have Emily ask hers. But it seems like a fair amount of the investigations are coming from Asia. Is there any ethnic predispositions involved in Castleman disease?
Yeah, it's hard to fully tease out. There are far more case reports that come from Asia, from Japan, from China than you see in the United States and across Europe. We're not sure if that's just because in Japan, there's this love for Castleman disease in Japan. It's in part related to the IL-6 connection. And so they love Castleman's there. And every patient that any Japanese doctor sees, they write up a case report, and it's a big deal. And so we don't know if it's just this kind of reporting bias, whereas, as you know, American doctors don't have time to write up case reports. And so, you might see 5 cases in your career and you not write up any of them. Whereas in Japan, you'd write up all 5. So it's hard to know, but it looks like there may be increased numbers in Japan.
Okay. Emily, are you there?
Yeah. Can you hear me?
Hey, Emily, yep.
Yeah, I think you kind of already answered that this is idiopathic and we don't really know where it's coming from, but I was just curious if you thought that there was a genetic component to this, or whether it's more of just an immune response to something in the environment or a combination of both, probably most likely. I was just curious as to where you guys were with that kind of research.
Great question. I think early on, our strongest hypothesis was we assumed that there must be some virus that we're just not detecting. And so we've been chasing a potential virus for quite some time. We've done 3 different approaches to look for viruses with a group at Columbia, the group at Penn, and the group at the NIH. That's what they do. They're viral hunters. They're the same people who, when a new virus emerges, like SARS-CoV-2, they figure out what is that virus. So we've been working with 3 different viral hunter groups for all these years and have not been able to detect any sort of new virus. So in patients, we often find evidence of a historic EBV infection. We find out that in all of our controls too. And so so thus far, we haven't found any sort of a smoking gun viral infection, although it feels so viral because it's so acute and it's so aggressive. But I guess the one thing against that is that immunosuppression gets people out of these cytokine storms. You crush the immune system with chemo and you get better, which obviously that's not typical if it's a pathogen. So we're still trying to figure that out. We've done a lot of pathogen work. We've done a little bit of work into autoantibodies that might be involved. We are also doing some work into germline mutations that could be involved, but also somatic mutations. Like Alan's question around clonality, if there was a clonal population, those cells would harbor a somatic mutation.
Okay.
So Suzanne, you had a question, Suzanne?
Yeah, your book, David, your book was very inspirational. I read it like a year ago or so.
Oh, that's wonderful.
And I'm a rheumatologist, and so a lot of this really spoke to me because it's very much what we see in some of our autoimmune diseases.
Yes.
The cytokine storm, the hemophagocytic syndrome,
Yes.
the IL-1 receptor,
Yep.
things. And I was really inspired, but I had a question in terms of, you were able to take this question of what's causing my unknown disease and actually do something about it. And I wondered, how did you make that bridge? How did you actually get to do that? Because when I think of the patients of mine who I see, and we all sort of throw our hands up and we're like,
Yep.
you have something like this, but we're not
Yes.
quite sure. I don't know that I would know how to go and do that and be successful in that.
Yeah.
And I think all of us have probably had those patients that we just say, we really don't know what you have. We're going to blast you with steroids. We're going to blast you with cytotoxic therapy.
Cytoxin, yep.
How do you actually make that transition so that if you had that question, you could follow up, you could try and do that for your patient?
It's a really good question. I think that in my case, I was fortunate that I got so sick so many times that, and I survived each of those times, that I knew that I was kind of like up against a wall. I knew that there was no future in front of me unless I found something. And I was fortunate to be at Penn, where there are labs kind of everywhere, and they're studying the immune system at every corner. And so it meant that I could kind of immerse myself into that setting and trying to find some mentors that could help to guide me. I could work with my colleagues. I mean, I think that the quarterback analogy, I think, is really important because it wasn't as much me performing the studies, and it wasn't as much me knowing what to do. It was more me like wrangling the people together, getting the experts to talk to one another, getting them to communicate with the immunologists, figuring out, if we've got limited resources, limited samples, what's the only study we should do? If we can only do one thing, what are we going to do? So I think that my situation is quite unique because the data we had already generated, like those cytokine, I'm sure you've run cytokine panels on your patients before and probably not really known what to do with them because there isn't great data on like, if IL-2 is up, should you use an IL-2 inhibitor? There's not really good data on just because it's cytokines up means that blocking it's going to actually work. But so we had all this cytokine data because my doctor loves to run cytokine panels, but it was at different hospitals. And so just pulling it all together in one place, this trend emerged. And it was like, okay, every cytokine's through the roof when I'm in the ICU. Maybe that's to be expected, but a couple of them started to rise early on. And it's sort of like, well, maybe we're onto something. And we might have not have been on anything, it very easily could have been that there was no smoking gun there, but we pursued it. And I think it also, like I said, had to do with the fact that we were just totally out of options. That made us feel like, we could take this, this leap of faith.
All right, I think we're going to call on Mitch, and then we have Rich Edelman.
I think that'll be it. 2 more questions. We don't want to take everybody's time further, but go ahead. Mitch, you had a question.
Your talk was breathtaking. I appreciate it. You're a wonderful tribute to your parents. We all know your parents, and they were spectacular people. And you are a good tribute to them.
Thank you.
I'm a neurologist, and I use interferon like water. Tell me some more about the role of interferons in this cascade of insanity.
Yeah, in the COVID setting or the Castleman setting?
Both.
Sure. Sure. So and it's a good point to say both, because in Castleman's, we found, we did single cell RNA sequencing recently, and we found that there's this really strong interferon, type 1 interferon response signature. So cells in Castleman's patients during flare are expressing all of the genes as though they are just getting riled up with interferon, which is something you can see in lupus. So there's a very strong interferon signature in lupus. It's also something you see in infections like SARS-CoV-2, but there's this really, blazingly strong interferon signature. And then we took that a step further, because we've known about the interferon signature. We knew about the mTOR signature, and JAK is a critical mediator. The JAK signaling pathway is a critical mediator of both interferon signaling and also mTOR signaling. And so we did some in vitro work in our lab where we said, well, if there's a strong interferon signature and a strong mTOR signature, and JAK is a mediator of both, why don't we try in vitro, so in a dish, why don't we try treating cells with JAK inhibitors and seeing if we can get them to calm down? And we were able to. So using JAK inhibitors in Castleman cells and also in healthy control cells, we were able to show that this like hyper interferon mTOR picture can actually be reverted with a JAK inhibitor. So that's exciting from a therapeutic perspective, because JAK inhibitors, some of you all may use them. They can be quite toxic. They're not the most easy to tolerate drugs, but they're better than some of the chemo that we usually give to Castleman's patients. And so, so it might be an exciting move. The same thing is seen in COVID, and that's where I was saying we've done the exact same single cell RNA sequencing analysis on blood cells from COVID patients, and we found an almost indistinguishable type 1 interferon signature. We also found tons of mTOR activation. Actually, we found even more mTOR activation in our COVID patients than we found in our Castleman's patients. So, so there's a really clearly this interferon, there's excess interferon signaling, but then as you may have seen a few weeks ago, there was some data about some patients that had antibodies against interferon. So they might be making interferon, but because they have antibodies against their own interferon, it might not be doing what it's supposed to be doing. So like your immune system's trying to fight off this virus, it's cranking out a ton of interferon, but all the interferon it can make, those people have autoantibodies against their own interferon, and stopping the interferon from doing what it's supposed to do. And so it's kind of it's kind of confusing for me how to like piece this together totally. But I think there's clearly a strong signal that interferon, maybe not too surprisingly, is part of this whole cascade. I wish I could delineate it perfectly, but I can't.
Thank you.
Yeah, absolutely.
You did.
Yeah, let's go with Rich Edelman. Are you there, Rich?
I have to figure out how to unmute me. Okay, so David, thanks again for your talk there and everything. What I want to know is more about coronavirus. You were on People's Pharmacy talking about it a couple of times. Any progress since then? Are you any in vivo, in vitro drugs that look promising? What's your feeling about that?
Yeah, so that same drug, ruxolitinib, I mentioned earlier, or baricitinib, it's almost magical in that it's such a good inhibitor of both type 1 interferon, type 2 interferon, mTOR activation, IL-6 signaling. It's almost like all of the cytokines that we see elevated in COVID all seem to signal through either JAK1 or JAK2. And so I think I think using ruxolitinib or baricitinib is super interesting. A challenge, so there actually are trials that are going on right now. The challenge is finding the right timing. So this like Dex, I think is gonna be better in late stage. If you give it early, I think that's probably a bad thing. So that's the challenge right now with COVID, is that you have to think about it. It's almost it's a 2x2 diagram where you have to consider, are they really acutely ill or not acutely ill? And is it early or say not acutely ill, early, late? And there's going to be different drugs depending on which of those 4 quadrants you're in. And so, remdesivir is great early. And if you're not that severe, it really seems to have no effect if you're late and severe, versus dexamethasone is the exact opposite of that. I would expect baricitinib to be the opposite of that. I'm trying to think what other ones, baricitinib and ruxolitinib are 2 of my favorites right now that I would bet heavily on. And then You know, I'm really pretty positive about these monoclonal antibodies, where you have the Regeneron has made, and also Eli Lilly has made, that Trump received. I think I'm excited about them for the short term. I think my concern about them is that if you supplement someone with antibodies, they're not going to make the same antibody response. So they're going to then not have the immunity that someone else would longer term. Now, you might say, like, let's save the life and you'll deal with it later on, which I agree, because you'll probably have some amount of immunity the second time you hit it. But that's certainly a risk.
Wow. David, this was great. Really and truly, thank you so much. I hope someday we'll see you here in Raleigh.
Yes.
In person. Really spectacular, and thank you. And you've inspired us all, and we've all enjoyed it. The chat has been filled with complimentary statements by everybody. So I'm going to let you go and get back to your family. Thank Caitlin for enabling this. She was great to work with. You're both lucky people to have each other.
We're very lucky, and thank you guys all so much. It's really, really wonderful. I love the questions. I wish that I had answers for all of your questions. I feel like I had bits and pieces of answers, but that's why we work all day, every day. So hopefully we can actually get towards real answers. But thanks for all the work you guys do as well, and thanks for having me.
Thank you.
Thank you.
Bye-bye now.
Bye, guys.